Okay, system of linear equations. We all know what a linear equation is. An equation of the form y equals mx plus b is a linear equation. And we know m is the slope and b is the y-intercept. As an example, y equals 2x plus 5 is a linear equation. But here we are trying to find a system of linear equations, or form a system of linear equations. So I have that equation y equals 2x plus 5, but I can sort of rewrite it in the general form. I mentioned this in one of the videos long time ago. I can rewrite the same equation in a different form. For instance, I can move the 2x to the other side. So I have 2x, that becomes negative 2x, plus y equals 5. It is the same equation, I just rewrote it so that I have x and y terms on one side and just a number on the other side. So that equation is still a linear equation. Now, suppose we have two equations, linear equations. One is y equals 2x plus 1, and the other is y equals 4x plus 1. I can rewrite both of them. I'm moving the 2x from the right-hand side to the left-hand side in the first equation. I'm going to do the same with the second equation. So I'd have minus 4x plus y equals 1. And that is what we call a system of linear equations in two variables. In this case, the variables are x and y. We call it a system because we have two equations. Now, of course, there are system of linear equations in 3 variables, 4, 5, 10, 15, 100. We can keep on going. But as far as this class is concerned, we are simply going to look at our system of linear equations in 2 variables. But what is the objective here? The objective, or the goal, is to solve for x and y. So we want to come up with a number for x and number for y that will satisfy the system. What do I mean by satisfy the system? It must satisfy both equations. So once I find the x and y values, when I plug it back in each of the equations, both equations must verify. The left-hand side must match the right-hand side. In other words, say I have a value for x and I have a value for y. I plug it in the first equation, I must get 1 on the right-hand side. I plug it in the second equation, I must get 1. Unless both of them are satisfied, we don't have a proper solution. So the goal is to find values of x and y that satisfy the system. What does it mean? I mean, we could find a solution, we could find x and y, but what is the meaning of that solution? So I'm going to go back to the system. It's negative 2x plus y equals 1, negative 4x plus y equals 1. But I know that both of them came from different lines. So let's look at the first line, which is y equals 2x plus 1. And we rewrote it as negative 2x plus y equals 1. The second one was y equals 4x plus 1. And we rewrote it as negative 4x plus y equals 1. So for the purposes of graphing, I'm going to use the standard slope-intercept form. And both of them have an intercept of 1. So I'm going to use green for the first line. And blue for the second line. Since both of them have the same intercept, y-intercept, and that y-intercept is 1, I could draw a line through that. So I need another point because if we have to graph a line, we need 2 points. So I know one of the points is 1 because that is the y-intercept. To find the other, I can simply plug in x is equal to 1 in the first equation, y equals 2x plus 1. And that would give me 3. So same y-intercept. And I could draw a line through it. The next line is the one in blue. And if I plug in, let's say, negative 1, Oh, that wouldn't work. How about +1? If we did +1, it's going to give us 5, which is outside of this. Let's see, maybe 1/2. If I plug in 1/2 in the second equation, we have 4 times 1/2 plus 1, which is simply 3. So this time we have 3 when x is 1/2, which is right over there. And that is our second line. But the y-intercept of the second line is same as the y-intercept of the first line. So I can draw a line through it. And that's what I would get. So when we solve for a system of equations, this point of intersection is simply the solution to the system. So anytime we try to solve for a system of equations, what we're trying to find is the point of intersection of 2 lines. Now, this geometric interpretation works for 2 equations, 2 variables. Now, when we have 3 equations, 3 variables, then it's no longer a line, rather it's like a piece of paper. It's a plane and it will intersect at 3 different points. So where do the 2 lines meet? And that intersecting point is the solution to the system of linear equations. As a remark, we know something quite interesting about parallel lines. So parallel lines never intersect. And if 2 lines are parallel to each other, then they're not going to intersect at all. This would imply the system of equations So a system of equations with 2 parallel lines will not have a solution, period. So for us to have a solution, the 2 equations should correspond to 2 different lines. Otherwise, we will not have a solution because there will be no point of intersection. So here we have 2 linear equations, and it forms a linear system of equations. They have given us an ordered pair, an xy point, and they want to know if that xy pair would be a solution to the linear system. As I mentioned earlier, an xy pair is a solution if and only if plugging in the values satisfy both equations. So step 1, I'm going to plug in x is equal to 2 and y is equal to -1 in the first equation. So I would have 2 minus of -1 equals 3. 2 plus 1 equals 3, which would mean 3 equals 3, and that is valid. So the ordered pair satisfies the first equation. Now I'm going to plug in x is equal to 2 and y is equal to -1 in 2x minus 4y equals 8. So we have 2 times 2 minus 4 times -1 equals 8. 2 times 2 is 4. -4 times -1 is 4 equals 8. 4 plus 4 is 8, and that is verified also. So we can conclude that 2, -1 satisfies 2x minus 4y equals 8. So this would mean 2, -1 is a solution to the system. Common mistake is oftentimes someone would verify one equation and not the other. The moment it satisfies one, they would end up calling it a solution, but that is incorrect. For an ordered pair to be a solution of a linear system, it has to satisfy both equations, not just one. Okay, so here we have a weird system. Here, y is equal to -5x and x is equal to -2. I'm going to rewrite this as a linear equation so you can see exactly as to what we have. So the first equation, if I move the -5x to the other side, it becomes +5x. In the second equation, there is no y at all, so I can write it as x plus 0 times y equals -2. Any number multiplied by any other number is always 0. So I didn't do anything wrong by writing it that way, because 0 times y is 0, and 0 plus x is simply x on the left-hand side. Now, perhaps I'll write it in order. 5x plus y equals 0. X plus 0 times y equals -2. I know from experience that both of them are lines, and one of them is actually a vertical line, x is equal to -2. But rewriting it this way helps you realize that, okay, even though the problem doesn't look like the previous one, if I rewrite it, now it looks like a system in a linear system in two variables. So first step, I'm going to plug in -2, 10 and 5x plus y equals 0. So we have 5 times -2 plus 10 equals 0. 5 times -2 is -10. -10 plus 10 would equal 0. -10 and 10 would get cancelled, so 0 would equal 0, so that is satisfied. Plug in -2, 10 in the second equation, which I rewrote it as x plus 0 times y equals -2. So plug in -2 for x. 0 times 10 equals -2. So -2 plus 0 would equal -2. -2 plus 0 is simply -2, so that checks out too. Since -2, 10 satisfies both 1 and 2, we can conclude -2, 10 is a solution to the system. Okay, so I'm going to rewrite the first equation. Oh, it's not necessary. It's just 4x plus 5y equals -7. So plug in x is equal to 3/4 and y equals -2 in 4x plus 5y equals -7. So we have 4x is 3/4 plus 5, y is -2, and we must get -7. So 4 and 4 will get cancelled. We have 3. 5 times -2 is -10. 3 minus -10 is -7. -7 equals -7, so it checks out. The second equation has -8x equals 3y minus 1. It's not in the standard form, so let me just bring the y term to the other side and leave the -1 on the right hand side. So -8x minus 3y would equal -1. 3y moves to the other side, it becomes -3y. And plug in x is equal to 3/4 and y equals -2 in -8x minus 3y equals -1. Keep in mind that equation and that equation are one and the same. We just rewrote it. So -8 multiplied by the x value, which is 3/4, minus 3 multiplied by the y value, which is -2, and it must equal -1. The 4 and the 8 would get cancelled, so we have -2 multiplied by 3 minus 3 multiplied by -2. -2 multiplied by 3 is -6. -3 multiplied by -2 is +6, and that would be -1. And -6 plus a +6 is 0, so we end up getting 0 equals -1. And that just can't be true. 0 is a different number from -1, so it doesn't work out, or it isn't going to work out there. So the ordered pair satisfies the first equation, but not the second, which would imply 3/4, -2 is not a solution. So the key point to take home is that an ordered pair has to satisfy both equations in the system for it to be a solution.